Hello, this is for Physics 2212, Lab 2, and the purpose of the lab is to estimate the amount of charge on each tape necessary to float one above the other. The main principles used in this experiment are Coulomb's law and the electric field of charge distributed on a rod, which you will see further in this report is related to Coulomb's law. In the end, the experiment found that the total number of electrons found was to be 9.16875 times 10 to the 10. In lab 1, by placing one U-tape below another and by measuring the distance between the two and also measuring the top tape's weight, we were able to determine the excess charge on a U-tape. The assumption was that the tape was a point charge where all the charge was at the center of the tape. In this lab, we are assuming instead that both charge U-tapes have the same amount of charge and that the charges are evenly distributed along the length of the tape. Of course, Coulomb's law does not change. We are still assuming both U-tapes have the same amount of charge. Thus, to find the amount of force between two charged particles, we must multiply Coulomb's constant by particle B's charge squared and divide by the distance squared. Finding the electric field from a rod is also very similar. Instead of a point charge, we are taking a very small portion of the rod. This very small portion is practically a point charge, and by taking its charge dq1, we can then calculate its electric field onto a point, dE1. By continuing to take these very small portions of the rod up to its length and finding the electric field, we can sum all the electric charges from dE1 to dEI to end up finding the net electric field, E net. Since we have two tapes, we are measuring the electric field of a rod onto a rod, but the way to find the electric field is nearly the same. We can find the net electric field of a really small portion of the rod slash tape by summing all electric charges from dq1 to dqi to find dE1 net. And then by continuing to find the dE net throughout all the top of the rod, we can sum all the values from dE1 net to dEI net to find the total net electric charge on the top rod, which is, in this case, is our tape B from the bottom rod, tape A. Here you see the glow script program to depict the rod made out of 10 point charges, or 10 DQs. By using the Q found in lab 1, the electric force found was to be equal to 2.2521 times 10 to the negative 4 of newtons and is represented by the very small white arrow. The gravitational force remains the same from lab 1, equaling to negative 1.962 times 10 to the negative third newtons, and is represented by the yellow arrow. The green arrows represent the electric field exerted on each DQ for the top tape. Here you can see the code used. There is the function to find an electric field of a point charge on line 36. On line 111 to 127, you can see a for loop to iterate in calculating the net electric field and then the net electric force on each DQ on the top tape. The forces were then summed to lead to find the net electric force on tape B. A likely source of error in why our electric force was different to our gravitational force was that our Q was inaccurate since we found it when assuming the tapes were a point charge. I found that a better estimate for Q is 1.467 times 10 to the negative 8 coulombs, where the force when there are 10 point charges is 2.225 times 10 to the negative 3 newtons. When there are 50 point charges, the magnitude is 1.809 times 10 to the negative 3 newtons. If Q did equal this estimate, there would be 9.169 times 10 to the 10 electrons. Now, what if I had modeled each of these tapes as a single point charge? Well, by using Coulomb's law and plugging our found electrical force of 2.2521 times 10 to the negative 4 newtons and solving for Q, Q would equal 1.58 times 10 to the negative 9 coulombs, or 9.875 times 10 to the 9 electrons, which is 33% of what was found from lab 1. Now, why do these estimates differ and which is more likely to be correct? They differ because in lab 1 we assumed that the tapes were point charges, which is obviously wrong because they have a length and width. Thus the estimates were different. This also means that our newly found answer of 9.169 times 10 to the 10 electrons is more likely to be correct. However, we only accounted for length and not width, so our answer is most likely to be off still. To conclude, in this lab, We estimated the amount of charge on each tape necessary to float one above the other under assumption that both charged U tapes have the same amount of charge that is evenly distributed along the length of the tape. And by using glow script, we were able to find Q to be more likely to equal to 1.467 times 10 to the negative 8 coulombs, also known to be 9.169 times 10 to the 10 electrons. However, since we did not also account for width of the tape, this answer is still most likely to be inaccurate.